I hope everybody is fine. And the very first question is why nothing can go faster than light? And if anybody tries, if you try to go faster than light, the limit that we have, the limit that special theory of relativity imposes on the speed of the objects. So, to move on for this argument, what I would like to tell you is the best way is to imagine, because you cannot do it without imagining. So imagine pushing the accelerator of your spacecraft, and suddenly time around you begins to stretch. Your mass begins to rise. Your perception of the universe warps, and you realize something profound. Like you are no longer fighting air resistance. You are fighting the structure of the reality surrounding you. This is the story of the fastest thing in the universe, the tail, the fundamental cosmic limit, the boundary that no object, no signal, no information can ever surpass, can never cross it. Today we'll explore why the universe has the speed limit and what truly happens if you try to break the limit of the speed. So what could we expect out of it? So hello everyone. I'm Arfat Firdaus, and welcome back to the channel. So in this episode, we're diving deep into one of the most misunderstood yet most important laws of nature. And was that nothing with mass can travel faster than the speed of light. But isn't just a rule of thumb. This is a law woven into the fabric of space, time itself. Break it and you break the causality, you break the physics and the flow of time. So today I will walk you through this journey. Why light is the speed limit. What actually happens as you approach to the speed of the light, and that's why infinite energy is required to reach it. What faster than light travels would imply, what it would mean like is the bizarre world of, it would be a bizarre world, and what this tells us is about the reality itself. So let's begin at the root, and space and time, the root of space and time. Why does the universe even have a speed limit? This is the very first fundamental argument that we are coming up with. And to understand the speed limit of the universe, we need to go back to the simple, maybe the revolutionary experiment that was ever done. The experiment that we know is the Michelson-Morley experiment. And most of the people are aware about this experiment, especially the physicists. So science once believed light needed a medium to travel, and maybe something they called the luminous luminiferous ether. But the time after time, the experiments after experiments, the experimentalists found that light has the same speed no matter how fast the source moves. It seems insane. This is insane. This is deeply unintuitive. If you throw a ball from a moving train, the ball's speed adds to the train's speed, right? That's what is the argument. That's what our intuition is. But with the light, this never happens. Light does not care. It doesn't care if you run towards the light or you run away from the light. So if the light is going this way and you move away from it, and the vice versa, the light doesn't it doesn't panic the light. You launch it from a stationary lamp, and whether you launch it from a stationary lamp or you launch it from a traveling spacecraft, its speed stays exactly the same, 3 times 10 to the power of 8 meter per second. Its speed doesn't change. That's when Einstein came along and said the most radical thing in the physics. If the speed of the light is constant, then everything else must change. So time must slow. The length must contract. The mass, the matter of the body must increase. Simultaneity must break down. Energy must rise dramatically. Even if I remember, he wrote the universe in one stroke. So what happens as you go faster and faster? So let's imagine you are sitting in future spacecraft. Not talking about the science fiction here. You're sitting in a future spacecraft, just a near future, and you start accelerating. You start accelerating at 10% the speed of light. Nothing unusual. You feel normal. But already time for you is slowing, although just by a tiny fraction. Now, if you move at 50%, your mass has increased significantly. Your spacecraft needs exponentially more energy to accelerate. Now, if your speed limit is up to the 75% of the speed of light, you have time dilation. The time dilation becomes noticeable. Maybe 1 hour for you is 5 hours for someone on the planet Earth. At 90%, your mass is now more than double your rest mass. Every tiny increase in the speed takes incredible amount of energy. So to go with 99% of the speed of the light, your mass might be 7 times your original mass. Because the time for you is crawling compared to the earth, someone on the earth. So at 99.9%, now the real craziness begins. To gain even 0.01% more speed, you need as much energy as small nations. At 99.5%, 5 times 9%, your mass is effectively thousands of times larger. 1 second for you becomes hours or days for the people living on Earth. So every push of your engine goes into the mass, not the speed. And right here is where Einstein delivers the knockout. At 100% the speed of light, your mass becomes infinite. And infinite mass requires infinite energy. And infinite energy does not exist in the universe. That's the wall. That's the cosmic barrier, the cosmic wall. That is the built-in maxima, the maximum of the universe. So the argument goes like this. Now we have the equations. The equation that sets this limit. Let's bring in Einstein's most famous equation, E equals mc squared. Now most people see this as a cute equation for nuclear reactions. The nuclear reactions, for fission, for fusion, but it means something deeper than that of nuclear fission and fusion. Mass is stored energy. And the faster you move, the more energy becomes locked in your mass. The true version it may be more powerful by incorporating a gamma, E equals gamma c squared, where gamma is the relativistic factor. If you put a gamma in between, and most of the physicists know that this gamma is 1 by under root of 1 minus v squared by c squared. Now, if you see the denominator of that equation, E equals mc squared, gamma giving, v is small, gamma is close to 1, you can check it. And when V is 0.9 C, the gamma is 2.3. So when V is 0.99 C, you can see the gamma is 22. When V is 6 times 0.999 and C, the gamma is in terms of thousands. And when V is equivalent to C, the denominator collapses. The denominator immediately equals 0. And the gamma becomes infinite. So the energy needed becomes infinite. So nature says you cannot cross this boundary. The boundary that I'm talking about. This is not a technological limitation. It's not the limitation imposed by the spacecraft. It's a structural limitation built into the geometry of space and time. This way we can realize it. This way we can have an intuitive. Now, if you could break the speed limit, that's our original argument. Suppose you are able to break it. Now let's hypothetically imagine you somehow push beyond this speed limit c, the speed of light. What physics predicts? It predicts bizarre, catastrophic consequences. What are they? The time would run in the backward direction, because cause and effect reverses. You could arrive before you left. You could receive signals before sending them. So in terms of information, meaning information flows backwards in time. This violates the causality, the backbone of the physics, the cause and effect kind of problem that we realize. And events will lose the order. It starts and it ends, but here the end is the start. The universe depends on the order of the events faster than the light breaks that. Relativity collapses. Space and time mixed in a mathematically inconsistent way. So, what would truly happen? Well, physics stops working. The equations produce nonsense, bullshit. The universe doesn't allow this path. You cannot take a path to cross the limit of the speed of the light. So, what about light itself? Why is it special that it can exactly have a speed what it has? People often ask this question: why can photons travel at the light speed while we cannot? To answer this question, the answer is elegant here. Photons have zero rest mass. They don't have mass if they come at rest. They have energy, they have momentum, but their rest mass is exactly equivalent to zero. They must travel at the speed of light, not slower, not faster. They have to travel with that speed. If a photon somehow slows down, even by 1 millionth of a percent, it would gain mass. And once it gains mass, it can never reach the speed of light. Light is the purest form of motion, the speed at which space-time itself propagates. Now, what about the warp drives and wormholes? You might say, but what about the warp drivers? What about the wormholes? They may be the good questions, the good arguments. These ideas do not violate relativity because they don't move through space faster than light. There's nothing like that you can move faster than light. Instead, the warp drives move space-time itself. You remain still in your bubble and space moves around you. And the other example is the wormholes. Wormholes, they are basically the shortcuts through the space-time. You take a shorter path, but locally you never exceed the limit that's imposed by the universe, the limit of the speed of the light. And however, to have these things in reality, what you need negative energy, you need exotic matter, you need massive stability issues, all of which are currently we have no ability to have these kind of things, the negative energy. So it may be possible. What was not possible 50 years back is possible now. Maybe someday it may be allowed. Yes, mathematically there is a possibility. The point is, when technology reaches that point, probably we don't know exactly now. So what we have tachyon, the hypothetically faster than light particles, which we presume as tachyons, Are these particles that always travel faster than light? Theoretical physics calls them tachyons. But tachyons come with huge problems. They would always move faster than light. These are the hypothetical particles that are predicted. They could never slow down to the speed of the light. They would allow, maybe they would allow the backward time travel. They would violate the causality. If these tachyons are real, they would destabilize the quantum fields. And so far, no experiment has ever detected these particles, the tachyons. We don't know if they exist. Most physicists believe they do not exist. You don't have the particles that can have the negative energies, that can have the speeds greater than that of the speed of light. Now, why this limit is a good thing? The limit that the universe has imposed on us. Now, if objects could move faster than light, the cause and effect will break down. Information could travel backward in time. The paradoxes will emerge. There are grandfather paradox is an example. Going back in time and meeting your grandfather. The laws of physics collapse. The universe becomes inconsistent. The speed of light is a barrier. It's limited in a cage of the universe. It's the foundation that keeps the universe logical. The way we perceive the logics, it protects the timeline, it protects the causality, it protects the structure. It protects the structure of the reality. Without this limit, the universe would be chaotic. And the physics that we know wouldn't work. And maybe the life will not exist. There will not be a life. There will not be any life. And light speed is really about space and time themselves. It is the limit, and here is the deepest truth about it. What I can tell is the speed of light is not the property of light. It is the property of space-time curvature. It is the speed at which the causality propagates, the information flows, the gravitational waves travel. The universe updates its state. It's the maximum speed at which the universe can communicate with itself. This number, what we have, if I give the number 299,792,458 miles per second, is built into the structure of our existence. 3 times 10 to the power of 8 meter per second. Now let's go back to our spaceship that we started with. Let's return to you in your spacecraft. You are pushing the throttle harder and harder. You have burned oceans of fuel. Your engines are roaring. But instead of accelerating, you notice something strange. Your fuel isn't making you faster. You're burning the fuel, but it's not making you faster. It's making you heavier. It's increasing your mass. All your energy is going into the mass. It's not going into the velocity as you expect. The burning the fuel will lead to the velocity. It's increasing the mass of your spaceship, of your body. Time outside is rushing faster. Stars appear distorted. Space compresses in front of you and stretches behind you. You are racing across the universe. But you can never break the barrier. You hit even at 0 point many times 9, and now 1 second for you is centuries for Earth. You have achieved intergalactic travel, but still you cannot surpass this c, the limit of the c, the limit of the speed of light. And that's beautiful. That's merciful, because the universe has given every observer, every photon, every maybe graviton, every bit of information, a rhythm, a universal rhythm, a cosmic speed, a built-in harmony. Now, I think I have bored you a lot. Now I want to conclude the beauty of the limit that you have. So why does nothing move faster than light? To answer this question, because the universe is built that way. Because the space-time is built that way. Because causality, logic, and reality itself requires it. The speed of light is not just a number. It's a boundary that defines what motion means. It's the upper limit of the existence. It's the heartbeat of the cosmos. It's the heartbeat of the universe. So the next time you see a beam of sunlight, remember this. You are looking at the fastest thing the universe allows. Not because the light is the speed, no, but because this is the speed at which the reality runs. I am Arfat Firdaus. Thank you all for watching.